Oh, yes.
Where's Rachel? Where is she? Where'd you... Harvey? Where did you put her? Where did Harvey put Rachel? Hello. Hello. You're watching Nerdish. I lost my shoe. You gotta put your shoe back on. Go with it. Very good. What are we doing here? Well, we do SAT, ACT prep for everyone. Yes, and the question is not where is Rachel, but when. 8 to 9:30 p.m. That's when Rachel is. Tuesday, Wednesday, and Thursday. Watch it. Just see what it's like. It's for free. All week long. You can ask us questions like where's Rachel and what you do with Rachel and where is Harvey Dent. They're both studying for the SAT. It's a very important test if you want to go to college or university. Nice. I should have said university first because it rhymes. Oh, that's Catwoman. That's okay. I think we know Catwoman because we're Batmen. Let's do a problem. Yeah. We did exponents last time. What should we do? Let's factor a quadratic. Okay. Man, when it comes to education, I'm an addict. Oh my god, but not that kind of addict. No, just a quadratic addict. I hope this is factorable. Oh, it's gonna be factorable. Add 6. Okay. 6 is for Rachel. Alright. Let's take out a 2. Let's make it equal to 0. That's a good idea. Okay. So let's factor out 2. X squared minus 2. How much time do we have before Rachel explodes? Ask Harvey. Harvey. Multiply to positive 3, add to negative 2. I don't think that's possible. Oh, shoot. That's okay. Sometimes you can't factor quadratics. And sometimes you can't save Rachel. I was about to say that. I'm so sorry. No, it's good. It shows that we're tight bonded. Like Tight Bond, original wood glue. It has a tight bond. Like me and Levi.
All right.
Hello.
It is our favorite time of year.
It's the Cram Session time of year. It's an extremely short time of year.
It's literally, well, it's one day in May, but there's a couple of these throughout the year. It's like a holiday that has it's like a chain restaurant, but it's holidays.
Yeah.
And here's just one of them in the local neighborhood. But
that's exactly how I would describe this too.
Right?
Yeah.
Yeah. And it's a good one. Like the one in your local neighborhood, this is a good one. You've been to some other ones. You know what you're getting yourself into, but like you're glad because you know the waiters and waitresses.
Ring Matthews,
And,
hello.
hello, Ring Matthews. Welcome. It's
Did you
a
get a
big
haircut?
day. Yeah, actually, Ring Matthews does look a little
That
different.
looks good.
Yeah. It's a little shorter on the sides.
Very nice.
Levi and I have talked about
Yeah.
how that we think that would benefit you.
Yeah, Matthew, you look really good with the high and tight.
Yeah.
Looks nice.
Real high. Anyway, the SAT is tomorrow.
Yeah. How do you feel about that, Matthew?
Are you ready? Wait, is that... He did get a haircut. When?
That's awesome.
Like,
Did you get it today?
are you serious? Don't tell us you got it today.
Don't tell us.
Tuesday. What's today, Friday?
Well, we saw you the last 3 days.
Yeah, we didn't know.
Yeah.
So, yeah, exactly.
But you finally washed it, so that's why it looks
Right.
like...
And all those extra hair pieces,
Hairs
finally came out.
Yeah.
Call them hairs. Individual hairs.
Yes.
So the hair piece is like a wig,
Yes.
right?
Matthew, do you have any questions?
Yeah.
Thoughts, comments, concerns?
Suggestions.
Dreams?
Nightmares.
Ideas?
Hopes.
Little thoughtsies?
Thougtsies?
Thoughtsies.
Little thoughts.
Little thoughtsies.
Yes.
Yes.
Well, apparently Tuesday. Not really.
Yeah, didn't seem like
Us
it.
neither.
Yeah, they cut off a little more than just hair, didn't they, Matthew?
Oh.
Boom.
He got you real good.
Got you very well.
He's saying that they cut off your brain. Right?
Yes.
Yes.
Yeah.
Hey, Levi, you got something growing on your neck, and it's really ugly. You probably should get it cut off.
Is it my body?
No, dude.
Oh.
It's like right around here.
Oh.
And you
I
just...
grew head down though.
Did you?
Yeah.
Oh, one of those.
Yeah.
Did they just It's like 3D printing.
It's similar.
They completely printed your head first, and then
Yes.
slowly moved down your body.
Yes. Yes.
Well, you know what they say about people that were created that way?
Yes.
They're superior.
Right. In Greek.
Yeah. How about writing section when they say, should this sentence be added or deleted?
That's a great question.
Great question.
How about
Levi,
that?
Levi's going to pull it up. I'm going to give you just a little primer on that. So, this is fun. Something should be added if the following conditions are met. Number one, it must be relevant. It must be about the thing that they're talking about. Number two, it cannot be redundant. If they have already said all of the information that was in this sentence that they're talking about elsewhere in the paragraph, you don't want to put it again. All right? You don't need more information that's obvious or that's already been said. And number three, it must fit where they want to put it. Meaning, the sentence before it feeds really well into it, and then it feeds really well into the sentence after. If it should be deleted, you'll be able to tell because if you take it out, the sentence above and below will fit together really well, as though they were puzzle pieces that always needed to fit. And then finally, they got the chance to, and then they get married, and they run off.
They elope.
And they elope to
Yes.
their parents' chagrin.
Great deal of chagrin.
A lot of chagrin words.
It's actually what happened to Akira when he went to talk to.
Oh, that's
Chi.
right. Yes, about Naomi.
Yeah.
Yes, breaking all tradition. He came directly. He came directly. Breaking all tradition. Was that it? Would you have had a better reaction had he come the traditional route? I don't know the rest of it. Yes. Oh, man. All right, so should we get you got an example there?
Oh, I got.
Levi's got examples for days.
Yep. Okay, Matthew, like this one. And this is a bit. There we go. Okay, let's just toss it down there. And we'll go like, dang it. One moment. Okay. Yes. So, this is an adding and deleting question. You want to know my ideal, or what I would recommend is the ideal approach, or you just are bad at these? Either way, I'm going to say the same exact thing. So I'll just tell you my ideal approach. At this point, the writer is considering adding the following information. Okay. All right. So what everything Brady said was true. That was talking about how to identify wrong answers. Don't answer yes or no first. That's not a good idea because you're going to have to be proving 3 wrong anyway. Don't say yes or no because you might be wrong, and there's no point. So you'll get there eventually anyway. So we're going to look at just the reasoning. So after the word because. That's what we care about because we can identify relevance, we can identify validity, we can identify if it makes any sense, all those things. So do we want to add this sentence or this little phrase, ebooks, audio and video materials, and online journals? Okay, so a list of stuff, a list of different types of media, it seems like. Okay. This has nothing to do with that, Bird.
Oh.
Yeah. Okay. We have, it provides specific examples of the materials discussed in the sentence. Let's see. The sentence is where number 4 is. So the share of library materials that is in non-print formats, this stuff, is increasing steadily. So ebooks, audio, and video materials, online journals. Yeah, it does that. I'm not saying it's the right answer, but it does seem like specific examples of the materials discussed. So, yeah. B, it illustrates the reason for the increase mentioned. No, it doesn't. It does not illustrate the reason for the increase mentioned later in the sentence. We say these things are increasing, but it's not the reason for it. So that's not irrelevant because it seems relevant, but it's not what this is doing. So it's untrue. Then we have C. It interrupts the flow of the sentence by supplying irrelevant information. I don't love that. Maybe you could say it interrupts the flow of the sentence, but it's not irrelevant information. So I would cross out the word irrelevant in C. That's no good. And D, it weakens the focus of the passage by discussing a subject other than librarians. I also like that because the passage is about librarians, and it does seem to get a little bit off topic. So we have A, yes, because it provides specific examples of the materials discussed in the sentence. Now this is where we have two true reasons, A and D. And then we want to say, now we're asking, do we want this sentence? Which is a better argument? Because the SAT, unfortunately, says pick the best answer. So I would pick D in this case because we do care about the overall focus of the passage a lot. If both of these things are true and one of them seems to be a little bit too specific on too small a piece, which is giving very specific examples of non-print format materials, that's not what librarians are about. Now, in this passage, we are talking about librarians and their technological savvy and how they're becoming even more useful now. But going into examples of these small non-print materials is too small, unnecessary. So I would go with D. That's how I would approach this type of question. Do you want to see another one? Or are you fully comfortable with this? Did that put you to sleep, Matthew, or anybody else? How are you feeling? Sure, another one. Okay, Bird. I'm going to do another. Oh, no, not that way.
Do another one. I think it'd be fun.
That's a good idea. I didn't think of that at all. Where's this stupid mouse?
Hey, language.
I'm not allowed to say stupid?
Maybe.
Okay. Adding and deleting. So, here we go. Yeah. 15. At this point, the writer is considering adding the following sentence. Okay, so let's read this thing. Some scholars agree that the excesses of King Louis XV's reign contributed significantly to the conditions that resulted in the French Revolution. Okay. Now, let's go back to what we're talking about in this passage. This is about the narrator exploring different, I think, museum exhibits, right? Is that what this one's about?
Don't look at me.
I think that's what it's about. Yeah, the narrator is visiting the Art Institute of Chicago, and they're going through a bunch of different exhibits. So, right off the bat, this seems really specific about the excesses of a particular king's reign that led to a revolution in France. Also, revolutions in France, Actually, they're good at revolution. They're just not good at fighting other people. So, what?
They're good at revolution. They're not good at, like, the reforming afterward. Like, they never really stuck the landing.
Well, revolution,
because they had so many different governments afterward. Like, they never really had something solid.
Yeah, well, that's why they call it a revolution, because you're spinning continuously.
Well, no, we had a revolution, then we set it up.
France is very much a wheel country.
Continue.
It's shaped like a wheel, Bird.
Sure.
Okay, so A, it provides historical context for the Thorn Miniature Rooms exhibit. Is that about the Thorn Miniature Rooms?
So
I think so. I think that's true.
I've been there.
Oh, you have?
Yep, they're awesome. They're very cool. They're in the basement, and the rooms are tiny. But
so would you say that talking about King Louis XV's reign contributing significantly to the conditions that resulted in the French Revolution is good historical context for the Thorn Miniature Rooms? I would say yeah. It's decent. It's okay.
Yeah, it's not great.
Yeah, no, we don't like it. It obviously is probably the wrong answer.
It's so incredibly specific.
Yeah, it's way too specific. But it's not false. So we're not going to make it definitely wrong because we want to get rid of irrelevant information and totally wrong information. But A is probably going to be wrong. B, it explains why salons are often ornately decorated. Absolutely not. That's such a terrible answer. So B is wrong. And then it interrupts the paragraph's description of the miniature salon. Did it talk about it before? Yes. And does it talk about it after? Yes, it does. So I like C. It does seem to interrupt the description of the salon. And D, it implies that the interior designer of the salon had political motivations. No, it doesn't. It doesn't do that. So we're between A and C are the only ones that are true. But we don't really care about the historical context for the Thorn Miniature Rooms. We just care about describing them. So I think C is by far the best answer here. Now, me going through this is very cut and dry. It's very slow in the way that I'm doing it, but that's because I'm talking through it out loud. This approach should go just as quickly as any other, but you should not be looking at yes or no first. Do not answer this question immediately with yes or no. It's not. Yes, it saves time if you think, oh, I don't want this, and then you only look at the no answers. Yes, it does, but you don't need to. This is not where you should be saving time, because you should be reading all 4 answers in their entirety every single time you do a question. Every single time. So this is by far the best approach. It's the most accurate one. Don't answer yes or no right away. Okay, Matthew, other questions? I think this is relatively straightforward. Bird, you want to do some mathematics?
Yes.
Okay, I'm going to go post on Reddit.
Good division of labor.
Yes.
Late word.
There you go, Bird.
Did someone post
Mink,
something?
yo, what's up? No.
Mink.
Mink, do you have questions? Oh, wait, CB Turtle. We should do CB Turtle. CB Turtle, are you here?
Yeah, CB Turtle. We saw you posted a question. We want to answer it if you're here. If you're not, we don't want to answer it until you get here.
Did we do Hono's question from yesterday? When was this?
That was last night. Did you remember doing that?
I don't. Do you?
No.
This is inverses.
I got tons. Hold up.
Yeah, Mink.
Yeah,
Okay.
bring it on.
We don't believe
Send
you.
it our direction.
Yep.
Don't send it the other way.
Okay.
I cleaned my glasses before this, and apparently I didn't do a good job because they still are like all.
Yeah, I can't see you at all.
Really?
Yeah.
Jeez, it's not good.
Yeah.
Why don't I start with I don't know. I'll just throw a little distance formula on there until I get these questions. Distance formula is a good time.
Always a good time.
It's pretty healthy.
Yes, sir.
All right. I'll show you my version of the distance formula, which is patented, but not by me. All right.
How much are you paying to write that down then right now?
You bet.
Yeah?
Yep. All right. Let's ever want to find the distance between 1, 1 and 4, 5. There is a formula. I will write it, but there is an easier way to do this if you don't remember the formula. Ah, Minkyo. All right, give me a second.
Very good. I'll pull it up. You guys all know that formula?
All right. This is the distance formula. It's built off of Pythagorean theorem. What I recommend is just draw yourself a little circle, a little right triangle,
Yeah, same thing.
and figure out what your x distance is between the 2 points and what your y distance is. So we're going from x of 1 to x of 4, which is 3 units, and we're going from y of 1 to y of 5, which is 4 units. Those of you who know your Pythagorean triplets, this is going to be a 3, 4, 5 triangle, okay? Figure out what that delta x is and that delta y, and then just do Pythagorean theorem. And, this is what that is, but I think it looks a little intimidating. It's not. It's not. And, cool, we got a problem here. Oh, fantastic.
There were actually 3 Pythagorean triplets in my year in high school.
Were there really?
Yeah.
That's like
Sawyer,
statistically.
Taylor, and Grace.
Wow.
Yeah, I had French with Grace. She was the 4.
She was the 4.
Yeah, there's a 3, 4, 5.
Who did
Pythagorean
people
triplets.
most like?
One was like popular. One was really smart. The other was also really smart. And they were all very smart.
Yeah.
But like I never talked to the popular one.
But was the 5 the
Why
popular
would I
one?
do that? I don't know. Like
Right.
it was more like a 5, 12, 13 situation.
Say no more.
Yeah.
Yeah.
I don't know what that means. Do you?
It's like no. All right, talk about system equations after. You got it, Ring
Yes,
Matthews.
sir.
You got it. The graph of y is equal to the f of x. I don't know why I put the word on there. Is shown in the xy plane above. Which of the following could define f? Excellent. Okay, so here's what I see. I see 2 asymptotes. I see a vertical asymptote and I see a horizontal asymptote. Let's think about those here. Our vertical asymptote looks to be at around x equals -1. So our vertical asymptote is equal to x equals -1. And vertical asymptotes are created by dividing by 0 on the bottom. That's where you divide by 0. We don't like that. They create vertical asymptotes. Well, it's not that we don't like it or we like it. That's just what they do. It's just what it is. So we have to figure out which one of these would become undefined if -1 is the x value.
for A and B, x would have to be +1 for it to be undefined on the bottom, or 0 on the bottom, so it's not going to be those ones there. So I'm just going to go bloop and then bloop, which these mean it's bad. Yeah, okay. So C and D both give us x plus 1 on the bottom, which is good, because we want -1 to be the thing that makes the bottom 0. So that's cool. And then the other thing is we have this +1 and then this -1 business. Interesting. Okay. One of them has a vertical translation of +1. The other one has a vertical translation of -1. One thing you could do is the intercepts. The intercepts here will help you a lot. We have a y-intercept of 2. And so when we have a y-intercept, that means that our x value is 0 and our y value is 2. So which one of these will give us our y-intercept of 2 when x is 0? Let's think about that. The first one, we would have 1 over, x would be 0, so this would be 0 plus 1 minus 1. And then the other one is going to be 1 over 0 plus 1 plus 1. This is going to be 1 over 1 minus 1 gives us 0. Nope. 1 over 1, which is 1, plus 1 is equal to 2. That's the one we like. So this one is going to be D. That is good. Okay? C is not right. Now there's a couple other things to keep in mind. Your x-intercept could also work. So your x-intercept here is -2. So your x-intercept is what you have when your y value is 0. So if you set C and D equal to 0 and then try to solve for x, then that could also be a way to do this. And lastly, when you're doing rational functions, you don't usually deal with this vertical translation at the end. So what you could do is you could put it all on one fraction. Oh, I didn't know you could plug in the roots. Absolutely, absolutely. And remember, the y-intercept one isn't really considered a root. The x-intercept ones are considered the roots. Although we typically don't use roots to describe rational functions. We typically use roots to describe polynomials. But yeah, you can think of them as roots. Yeah, they give the whole equation a value of 0. Just to show you what I'm talking about, let's take C and let's make it all one fraction. So -1. We can't subtract 1 because it's not a fraction of the same denominator. Right now it's technically 1 over 1. If this had the same denominator, then we could actually subtract this and put it all under one fraction. So how do we get this to be the same denominator as that? Or how do we get them both together? It's not 3! It's not 3! You can always multiply denominators together. All right, think about fractions. You can always create a common denominator when you just multiply these things together. So I like 6, and then you turn both of those into fractions over 6. You got 3 over 6 plus 2 over 6 is 5 over 6. Same situation when you have these little expressions. You can always multiply them together and figure out what you can use as the denominator. So x plus 1 times 1, we're going to have a denominator of x plus 1. So all I have to do is I have to multiply this fraction by x plus 1 on the top and bottom. If I do that, I'm going to get 1 over x plus 1 minus x plus 1 over x plus 1. Now they have the same denominator. Now I can actually subtract. So this is going to be 1 minus the quantity x plus 1, which remember, the minus is going to apply to both of these. So 1 minus x minus 1. 1 minus x minus 1 over x plus 1. We have some cancellation here. We end up getting negative x over x plus 1. Okay? Which, if you're more used to this, that will tell you, okay, so like for a horizontal asymptote, for instance, this one would give you -1 as a horizontal asymptote, and our horizontal asymptote is +1. We won't go too much into horizontal asymptotes, not necessarily right now. If you want to ask us about it, they come up occasionally, but there might be bigger fish to fry that we should be frying. D will give you a horizontal asymptote of +1, which is what you should have. All right.
Are you fine with me posting this?
Let us see.
This is just the thing that it's this, but I literally just copied and pasted it.
I literally trust you.
Wow.
Yeah.
I'm used to figurative trust.
No, I literally trust you.
I feel it in my heart and my bones.
In your bones.
Yeah. My heart is a bone, though.
Yeah,
Minkyo.
Levi's heart is a bone.
Wait, how many more questions you got, Minkyo? Did you ask more questions? Nah. Oh, yes. We got one.
Well, should we do add to the queue, please? Please practice says math 2 question 3 and essay.
Whoa.
Cool. All right.
Wait, so we need to do systems of equations.
Yes.
First.
Absolutely.
Hey, Matthew, what do you mean by systems of equations? Do you feel comfortable with systems of inequalities? Is it graphing? Is it intersections? Is it
The three different possibilities:
Yeah, is it
zero solutions, infinite solutions, one solution.
Yeah, is it? Yeah, is it?
What? Yeah, is it?
Yeah, is it? I
Is
thought
it?
you were gonna keep going.
I don't know. I don't know. Specifically, systems of equations where they're both linear, or one of them might be quadratic, or something. You can answer their question first. All right. So Minkyo's question.
Okay.
Yes.
Sure. I'll pull that up. I already said. Good.
Minkyo. When they give you 2 or 3 equations and ask you to find x or y. Yeah, okay, system of equations. We can talk about that. You should have said so. Just kidding. Linear. Got it. It's my favorite kind of systems.
Ooh, how do you feel about the questions where they say make a, you know, they have ax, y, or ax plus 3y equals 5, and then they say what value of a makes it so that this system of equations has infinite solutions or no solutions, or what, that type of thing too?
We should pull up one of those questions.
Yeah.
Yeah. Anyway, a survey was conducted using a sample of history professors selected at random from the California State Universities, a very fine university system, I must say.
Oh, it's so
The
fun.
California State University system has a lot of solid schools in
They're
it.
very good schools.
The professors surveyed were asked to name the publishers of their current topics. What is the largest population to which the result of the survey can be generalized? Interesting. I understand those. He understands those. Okay. So we do surveys because we want to learn information about a population, but we don't talk to everyone in that population because that would take way too much time and energy and money. So we talk to a small, randomly selected portion of the population and assume that they are a good representation of the overall population, to which we can then make a conclusion. Okay? So they select at random a sample of history professors from the California State Universities. That is where these history professors are selected from. So there's a couple things that are very specific here. They're history professors, and they're at the California State Universities, so that is all they can actually represent, okay? So, all professors in the United States, no. They did not randomly select professors from all the professors in the United States. B, all history professors in the United States, no. They did not select randomly history professors from all over the United States. It was only the California State Universities. So as you can probably see, it's going to be C, just history professors at all California State Universities, because there was not all professors at those universities, it was history professors. So all they can represent is the population that they come from specifically, which is going to be C. You cannot extrapolate outward from that because there are more variables with different kinds of professors in different places that they're not taking into account of because they selectively chose that sample from that group. Very good. All right, so leave Mikio put another question, but we should do system of equations. All right, system of equations. No, that's not what I wanted. Oh, sorry. All right. So, let's do it. There's a line right there, and then we're going to have, let's say, okay, there's a line right there. It is two systems, I'm sorry, it's two lines or two equations, so this is a system of equations. And it visually is the easiest way to understand what's going on. These are not solved for y, but they could be. I think the easiest way to visualize a line is to first put it in slope-intercept form. So if I really wanted to, I would bring this over, divide by, this would be -4 thirds x plus 7 over 3. That's what y equals, okay? That's just an example. You could turn this into a slope-intercept form equation. You don't have to, though. Anyway, both of these represent lines. All right, the solution to a system of equations is an intersection point that both of those lines share. It is an x and y that fits in both of these equations. And there's a couple different ways to find that. But there's also a couple different possibilities for what might happen when you're trying to find the intersection point, okay? Possibility 1. They intersect. It's fantastic. Everyone goes home happy.
So there's that line, and then there's this line, and look at that, there's a point where they intersect that. That's fantastic, okay? Possibility 2. These two lines are parallel, and they never touch. As such, there will be no solution, because there's no point that they both have in common. All right? And then there is 3. In this possibility, the lines are actually right on top of each other. So it's kind of hard to draw that. You just kind of, take my word for it, right? They're right there on top of each other. Because they're the same line, any point from one line will be on the other line as well. And these lines go on forever, so there is an infinite set of points that are solutions to the system of equations. So this is infinite solutions. All right, now you might say, wow, like they're the same line? Like, how do we not see that? You are going to see something that looks like this. 2x plus 3y is equal to 9. 4x plus 6y is equal to 18. And if you look closely, you will notice that the second equation is just a multiple of the first equation. It's just all those numbers scaled up by 2. That's how two lines that are the same will look. One of them will just be a scaled up version of the other, to which you could just divide all those numbers by 2 and turn it back into the original line. They're both the same line, okay? So let's figure out what's going on here. They look like they're different lines. They're going to be different lines. So we don't have to worry about the infinite solutions thing. I mean, if it turned out that they were going to be infinite solutions, you'll see where this is going to go, and then we would figure out that something weird happens. Anyway, you cannot solve one equation if you have two variables in it. You can only solve it for one variable in terms of the other. But when you have two equations, then you can actually get it down to solving both of the variables for a certain number. So the very first step in solving linear equations, there's two methods. There's substitution and there's elimination. I'm going to show you substitution because it's more universally applicable to like other systems that might be quadratics and things like that. Elimination really only works for linear systems. So what substitution is you solve one of the equations for one of the variables. Doesn't matter which equation, doesn't matter which variable, whichever one is the easiest and quickest to solve, that's what you do, okay? I'm going to say that's the second one, solving it for x. There is only one move I have to make to get x by itself. With the rest of them, there's a couple moves I'd have to make. So I'm going to add 5y to both sides, and I'm going to get x is equal to 5y plus 10. That is step 1. Second step, why it's called substitution. You're going to take this expression, and you're going to substitute it in for x in the top equation. So I'm going to rewrite the top equation, but where I get to x, up here, I'm going to write 5y plus 10. All right, then we have plus 3y is equal to 7. Now, something magical just happened. We now have an equation that only has y's in it, only one variable, which means we can actually solve it. That is the point of substitution, is you want to get one equation with just one kind of variable in it, and then you can actually solve it for that variable. So this is going to be, I'm going to distribute the 4, 20y plus 40 plus 3y is equal to 7. This is going to be 23y is equal, I'm going to subtract 40, I'm going to get negative 33. This is not a nice number, but, whatever. Equals negative 33 over 23, and neither of those are divisible by anything, so that's what our y value is, okay? At this point, you just plug this number back in for y into any of these original equations, and you'll get x. I would recommend plugging it into this one right here. We already solved this for x, and since we're trying to solve for x anyway, this is going to be the quickest one to just take negative 33 over 23, plug it in for y. So it's 5 times that plus 10, you'll get your x value. And that's going to be your intersection point, whatever your x value is, and then here's your y value, okay? That's substitution right there, and you can use it for all sorts of things. Use it around the house. You can use it to clean up your car. You can, what else can you do? Can you feed it to one of your pets?
Oh yeah, just be careful.
Yeah, be careful, but there's a lot of pets that can eat and digest substitution. Dogs, there's certain breeds of dogs that do not take well to substitution. They like eating it, but if they do eat it, they get really gassy, and some of them die. So you don't want to feed them that. Anyway, Ring Matthews, how do you feel? If you're wondering what would happen with I'll show you what would happen with the parallel lines. So right now we have one solution. If we had this, I'm going to make this easy. our two equations might look like this. I'm going to make them already in slope-intercept form. Y is equal to 5x plus 2. And then the other one is going to be y is equal to 5x minus 5. They don't really correspond to these two lines, but it's the same thing. They both have the same slope, but they have different y-intercepts. So with substitution, one of them's already solved for y. Great. I understand making it look like each other. Good. And so if we were to set this equal in y over here, what we're essentially doing is setting 5x minus 5 equal to 5x plus 2. But if we do that, something real funky happens. All right, if you try to solve this thing, it's not going to work. So let's say we have 5x on both sides. When you're trying to solve for x, you usually want to get all the x terms on one side. All right, if I do that and I subtract the 5x's from both sides, they go away, and we're left with 2 is equal to negative 5, which is not possible. It's not equal to negative 5. You get something weird like that, that tells you you've got no solution. Yeah. Ring Matthews, I understand making it look like each other. Yeah, I'm not sure exactly what you mean by that, but is there anything here you want me to go over again? Or does this all make sense? There we go. Neulich. Questions for stream. It's good, it's just time consuming. Yeah, it can be, especially if the equations are more complicated. Yeah. It can be time consuming. If you've got a graphing calculator, I mean, don't do this starting tomorrow for the test. You want to get comfortable with this, but you can also plug in lines on your grapher and then ask the calculator to find the intersection point. There's a place in your calculator. It depends on what kind of calculator you have, but it will actually just, find the intersection point and tell you what it is. So that's kind of nice. Something you could do to speed things up, but then you still have to solve these for y. Okay, good. You got your programs, but for the no-calc side. Yeah, for the no-calc, the numbers aren't going to be like this for the no-calc, hopefully. They're going to make it a little friendlier, but this is the way to do it. Very good. All right. So Minkyo's question. Minkyo. How you doing, Levi?
Good.
You want to do Minkyo's question, or you still doing it?
Yeah, no. And you can do Reddit stuff if you like. Just find my post and do stuff.
You want to just edit and post, or what?
No, just see what it is and say hi on it or whatever. Wait, did you do no calc number 3?
No, because it's Minkyo's turn.
Oh, very good.
Yeah.
What is this?
43.
Nice.
Sorry, 15.
That did look like a 43. You're right.
Yeah, it's good.
Okay. All right, so 43, Minkyo. To recognize the question type is our first goal. So we have, if she had not achieved, she should not achieve, should she not achieve, and if she is not achieved. Okay, so right off the bat, to me, we have a sentence structure question because A and B have if in front of them, and C and D do not.
Oh.
So if makes things into dependent clauses, right? If you say Minkyo walks to school, that's an independent clause. If you say if Minkyo walks to school, that's a dependent clause. That can't be a sentence on its own because it's not a complete thought. If Minkyo walks to school, Minkyo will run into the neighborhood bully or something, like Brady or somebody.
Yes, that's me. I'm a bully.
So let's see. I mean, it doesn't mean that if is wrong here. But it does mean that we need to be paying attention to that. So we start the sentence with however. We don't really care about that. That's a non-essential. We can just ignore it for the purposes of this question. Let's just start with A. We have if she has not achieved the required weight. Okay, well, that doesn't make any sense. No person is achieved, although I think this is talking about a bear, but bears are not achieved either. So I think A is wrong because that's not the correct use of the verb or the adjective. People or things are not achieved. You achieve a goal. You do not achieve the existence of yourself. Yeah, that's weird. So I don't like A. Let's move on to the rest. So then we have if she had not achieved, or she should not achieve, or should she not achieve. Ah, interesting. So we have, however, blank the let's go with B, I guess. If she had not achieved the required weight by eating animals of other species, a mother bear will often eat her own cub, oh boy, in order to fulfill her nutritional needs. I don't like that because of the tenses. We have if she had not achieved, so that is extra past, or technically it's called I always think of it in French. What is it in English, Brady?
What is it in French?
Plus que parfait.
I don't know.
Perfect. Past perfect. That's what it's called. Past perfect. Okay? That's not... We have past perfect. If she had not gotten enough food, she will eat her cub. That doesn't work. It's got to be... If she doesn't get enough food, she will eat her cub. We go from present to future. Or we go from past to... or extra past, or whatever it is. The past perfect to the past. We don't have that situation with B. So B is wrong because the tense is incorrect in this relationship between ideas. Then we have she should not achieve. So she should not achieve the required weight by eating animals of other species. That is an independent clause. It also doesn't seem to make much sense, but technically it's grammatically correct, but it's an independent clause followed by a comma, followed by another independent clause, which is a mother bear will often eat her own cub. So we have two independent clauses separated by a comma, which is a comma splice. So we are left with D, should she not achieve. This is an idiomatic turn of phrase that transforms she should not achieve. It turns that independent clause into a dependent clause. Should she not achieve, that's the same thing as saying if she does not achieve. It is an idiomatic way of saying it. D is the correct answer. You don't have to know it's correct. If you see weird turns of phrase that you're not comfortable eliminating, that doesn't mean they're wrong. You can't just say, well, I don't get it, so it's wrong. You have to say, okay, well, A doesn't work because people or bears are not achieved. So it's a wrong verb and adjective combination. B is the wrong tense. C is a comma splice, so D is the correct answer. Please let me know if that doesn't make sense, Minkyo. How do you actually... Okay, so this question has two things to think about. Sentence structure and diction. Yeah, I mean, technically it's always about diction because you're choosing words. I don't particularly like that description of this question. This is tense and sentence structure. Yeah, tense and sentence structure. B is very much a tense question, or tense-related problem. And then the rest of them are, I guess, diction for A. You could say that. Yeah. Okay. What are we doing now? The no-calc number 3?
Yeah.
Okay. Thank you for choosing the test we're already on, Matthew. That's helpful.
You're welcome.
You're not Matthew, Bird. Number 3. Oh, right. We already have it up. Great. Okay.
I upvoted it.
Thank you.
You're welcome.
Guess I should keep that. Okay. So this is the old landscaping company job. This is sort of a building equation. Wait, afterwards, no calc 5, 7, and 9. Got it. Numbers 5, 7, 9. Okay, so we're doing number 3 now. And we'll get to the other ones. Minkyo, feel free to keep asking questions. You should. Matt, you taking the test tomorrow? Probably. Okay, a landscaping company estimates the price of a job in dollars using the expression there. Okay, so we have a landscaping company that charges that. Now we need to figure out what N and H are. That is exactly what they tell us next. So, N is the number of landscapers who will be working, and H is the total number of hours the job will take using N landscapers. Okay, so we're always just going to be plugging those things in. Which of the following is the best interpretation of the number 12 in this expression? Okay, So we have that 60 out front. That is a number that is just added on to the beginning. So that's the base price, right? If your job takes no time and no workers, you will pay them $60. It's similar to Alta Ipsum, where you're not paying, or you're not getting stuff. Whatever, it doesn't matter. Not a good relationship between these two things, ideas at all. So the 12 NH. So we have 12. Write this out. Pink. We have 12 times the number of workers, right? Landscaper. So we'll just call them workers. And then we have times H, which is the number of hours, total hours worked. Okay. It's weird because hours depends on landscapers. Not exactly. Because we're not changing the number of landscapers. We're not changing the number of workers, right? We are changing. We can, but it won't change the total number of hours. It's just saying the term that I was taught was man hours. How many hours of work is it going to take? That's all. So we don't have to come up with what 12 means on our own because they give us the answers. So let's just go through them. The company charges $12 per hour for each landscaper. I don't. You ruled out B and D. Okay, so let's go to there. B, a minimum of 12 landscapers will work on each job. Yeah, that doesn't make any sense whatsoever, so that's wrong. Good. And D, so I'll just put X's next to these guys. So B is wrong. And D, each landscaper works 12 hours per day. Again, I agree. That's wrong. Okay. More landscapers equals fewer hours, not less, just so you know. So more landscapers means fewer hours. Yes, it does mean that in this case. I wanted H to be the total man hours, but that's just this is total hours required. So it doesn't. Yeah. Okay. So yes, more landscapers means fewer hours. Correct. So we have A, the company charges $12 per hour for each landscaper. And C, which sort of makes sense, right? Because this is where you want to plug in numbers. If you say that you have, let's say n equals 3 and h equals 2. So it's the job takes 2 hours. 3 guys show up and they work for 2 hours and then they leave. That means that NH is going to be 6. You're going to do 12 times 6. So does A make sense? The company charges $12 per hour for each landscaper. I think that does make sense because each landscaper is working 2 hours. So therefore you have 6 hours that are worked by this company and you're multiplying that number by 12. So the company charges $12 per hour for each landscaper. I like that. Let's see C. The price of every job increases by $12 every hour. No. Because of what you said, more landscapers leads to fewer hours, means that the price does not only depend on the price of every job increases by $12 every hour. That's not true, right? I mean, if you have more workers, then you might not. It's not a perfect relationship. So C is unjustifiable here. I'm having trouble being able to explain that because it's wrong. The idea isn't quite there. This, put in your own numbers. It should help a lot. I'm going to see if I can come up with a better way to explain why C is wrong. The price of every job increases by $12 every hour.
Actually, got there?
Sure. I mean, so C is basically saying that 12 is the slope, right? But you have 2 variables. So if you have y equals 2h plus 60 for whatever reason, right? Then this would, not 2h, 12. 12h plus 60. If you have 12h plus 60, then C would be correct. The price of every job increases by $12 every hour that you add on. But because you have N and H, it's not really a slope for this increase in 1H anymore because you have another variable in there. So that slope relationship no longer exists.
Keep going.
I'm done. I mean, does that make sense, Minkyo or Matthew or anybody? How do you feel? It's a weird question.
H is the total number of hours the job will take using N landscapers.
Yeah, it's not a nice. It's not like they work this many hours, they have this many workers.
Right, but you end up with the number of man hours anyway. Like NH is number of man hours.
NH is number of man hours,
then,
which is why A is correct.
And wait, okay, yeah.
Yeah. I got confused because the price could depend on landscapers or depend on hours. Exactly. It does depend on both. Therefore, when you multiply N and H together, you get the number of hours overall that are worked. So these two together equals man hours, which is the term for how many hours have been worked in total. So if you have three landscapers and 2 hours on the job, that means that 6 hours have been worked. That is why $12 per hour for each landscaper makes sense. I mean, A is sort of like a double slope at the same time. It's saying $12 per hour per landscaper. It's a confusing question. I am surprised this is number 3. This is actually pretty hard for number 3. It should be pretty easy to get rid of B and D. But yes, C is difficult. Okay, you got it. Very good. I'll shut up. Let's do... Mika, do you have a question? Did you put a question in the Discord? No. Okay. So let's do another SAT question. Number 5. Bird, do you want to do number 5?
Yes.
Oh, fun. You'll like it.
Really?
Yeah.
I like it. It's fun. I like it.
Can you erase, though?
Oh.
Yeah.
That's going to be kind of fun. Let's see. I don't think I need to really erase any more than that. Oh, you're going to put it on the left.
You want on the left?
Yeah, I do.
Good.
You convinced me.
Did I?
Yes,
Oh,
you did.
know what I wanted.
Yeah, it looks great. Okay. We're going till 10:30, right?
10:30.
Yeah, we'll see what the demand looks like.
Yeah.
Hey, tell your friends. Everyone that you know taking the SAT, tell them about us. All right? Because we want to help as many people as possible, and it has nothing to do with us wanting to make our stream more popular.
Nope.
No, we're very transparent.
We would like.
Oh,
sorry.
You stepped on my
did.
footword.
Footword. Hate that.
Okay, if k is positive and x equals 7 in the equation above, what is the value of k? Well, there's a very obvious step to start here, which is just putting 7 in for x. It's like lazy that they didn't do it for you. So we want to make sure that that's 7 right there. So I'm going to rewrite this thing. All right, so 2k squared plus 17, here it comes, minus 7 is equal to 0. We're solving for k here. Solving for k. K is underneath the square root, okay? This whole thing, 2k squared plus 17, you cannot break that square root down at all. All those things are stuck together. It's different when you're simplifying a radical and there's no addition or subtraction. Then you can break things apart using division and then take the square roots of individual parts and all that stuff. You cannot do that here. So the only way to free the k from the bondage of being under a square root, I like to make things a little more colorful, is you got to square the square root to get rid of it. But you don't want to do it yet, because if you square the square root, can't you move the 7 and square it? I'm going to do that. I'm going to say you don't want to square everything yet, because really what you're not doing is squaring individual things, you're squaring both sides. 0 squared is just going to be 0, but if you square this, you're going to have to FOIL, and it's going to get messy. You don't want to FOIL here, because then you're going to have to get this squared plus 2 times that plus this square. It's going to be a mess. So you want to move the 7 over. when you're simplifying a radical like this, you want to get everything else on the other side before you pull the metaphorical pin and square everything. I'm going to square everything. It's going to undo that square root plus 17 is equal to 49. I squared everything. All right. Now it's just simply solving for k, like you always do in math class. 2k squared, I'm going to subtract 17. That's going to give me 32. Divide everything by 2. K squared is equal to 16. And then I'm going to take the square root of 16. K has to be positive, so I'll take this plus or minus square root of 16, which gives you plus or minus 4. But then I'm going to just knock out that negative 4. It's got to be positive 4. Positive 4 is your k value here. And if you didn't know how to solve this, feel free to put in your answers. Plug in the answers. See if they work. If it's A, it's going to be 2 times 4, 8, plus 17, which is 25. Take the square root of that, that's 5. 5 minus 7 is negative 2. It's not 0. All right, you can always just try those values. Anyway, there you go.
So number 5 is that was 5. Number 7. Here we go.
My turn?
Sure.
Minkyo, you gotta ask some questions. You're falling behind.
Where do you want the, you want top left or top right?
Top right, please. Hono! Hi. How are you, Hono? What's the value of this? Okay. So, right off the bat, you recognize that this is an exponents problem because you see a lot of exponents here. So that's what we're going to do. We have x to the a squared times x to the b squared.
Over x to the b squared.
Over x to the b squared. I just totally failed my all-state audition. Not in the best mood. Shoot. Audition for what?
Was this music? Playing an instrument?
Music.
Was this is theater related?
So Matthew, just so you know, this is a possibility. This does not equal x to the 2a. Because for it to be x to the 2a, it has to be x to the a all squared. That will be x to the 2a. So I don't know. That's a possibility. Oh, French horn and vocal. Cool. Cool.
But it didn't go well.
Can you? Yeah. Okay, so you're fine with that. So that's not an issue. Cool. So now let's do some exponent rules. That's what we're throwing at it. So we're gonna throw stuff at it. We're gonna do quotient rule first. So we're going to get x to the a squared minus b squared power. That equals x to the 16. Yeah? So I just did quotient rule there. This marker is dying a little. And then next step, we have the same base, so the bases just go away.
Levi.
Yes.
I'm gonna go grab my water bottle.
Where is it?
It's upstairs.
Okay, on your way down, can you get my laptop charger?
Yeah, where is it?
It's on the table.
Okay.
You'll see it.
Okay, bye.
It's still plugged into the wall, so make sure you unplug it. So this will be a squared minus b squared equals 16. Now, the question gives us a plus b equals 2, and it also asks us what a minus b is. We will not be able to solve for a or b individually, because this equation, we have two equations. We have this original big scary thing that they gave us at the beginning, and they also gave us a plus b equals 2. So that's 2 equations and 3 variables, which means you cannot solve for them. You need to have at least as many equations as variables to solve for those variables. You said, oh, whoops. Was it a simple mistake? Changing answer to A. Yes, that would make more sense. So another simple mistake? Okay, so in this case, you have to recognize that this is a difference of 2 squares. So this will be a plus b times a minus b. That equals 16. We are given that a plus b equals 2. So now we know that 2a minus b equals 16. So we divide both sides by 2, and we get a minus b equals 8. So The answer is A. Very good. Do you have any follow-up questions on this?
I got you, Georgia.
Thank you, Bird.
It was on the table.
Right. I'm sorry. I should have told you that's where it was.
It was plugged into the wall
right.
on the table.
Oh.
Keep going.
My memory is going. Okay. Questions? Anybody? Thoughts, concerns, comments? No. Cool. All right. Stream's fine. Okay. Next, that was number. What number is this? 7. So
I will do number 9.
you will do number 9.
I will
Let's
do
see,
it.
Can I just scroll down? No, I don't think so.
Nice try. Oh, you're scrolling down.
I know, but it's on the left side.
Oh.
So
There's number 9. This is gonna be exciting. I don't know what that was.
whatever it was good.
Good. All right. The graph of a line in the xy plane
Oh, so
and
obnoxious.
slope of 2.
The slope of 2.
Oh, little slope. And contains the point 1, 8. The graph of a second line passes at the points 1, 2, and 2, 1. If the two lines intersect at the point AB, what is the value of A plus B? The
You
very
sounded
end.
like Patrick Bateman there. Patrick Bateman?
A little bit, yeah. Patrick Bateman
Yeah.
from American Psycho. The very end here is something that the SAT loves to do, which is they add one final little step here. So, like, the ACT would end it at, what's the intersection point AB? They want you to just one more step and add them together. All right, so
And why do they do that, Bird?
because they want to test your ability to read everything.
And so that you can't plug in.
Plug it in, plug it in.
You're not able to plug this in
Oh.
successfully.
I assume.
I assume that's why.
That's actually, I never thought about that. And that's really, I'm sure that's why it is.
Yep.
All right. So we have a system of equations here. We just don't have the equations yet. We got to figure them out. So the first one, if you have a slope of 2 and you contain the point 1, 8, there are two things you could do with that. If you like slope-intercept form, you're going to love this. Y equals mx plus b. The thing that we know is the slope, which is 2. This is y is equal to 2x plus b. The thing that we're missing is the y-intercept, but we have a point. We have a very good point, 1, 8. We're going to plug that in for y and x, and we can solve for b. 8 is your y value, x is 1, and then your b value, oh, no, not equals b. Whew, would have been bad. Plus b. So 8 is equal to 2 plus b. We subtract 2 from both sides. b is equal to 6. Great. So our first equation is y equals 2x plus 6, which I'm going to write up here. Our second equation goes through 2 points. So we have to go back and we have to find the slope. So, all right, got to remember that slope formula. So here we're going to have, the slope's going to be 1 minus 2 over 2 minus 1. Remember that is y2 minus y1 over x2 minus x1. Stop on your right foot. Don't forget it. Now it's time to bring it around town. Okay, we're going to subtract negative 1 over 1, slope of negative 1. Now we're going to pick up right where we left off with the previous one, where we have a slope, but we have a point. We have a very good point. So we have y, again, is equal to mx plus b. We know one thing, it's the slope, negative x plus b. We're going to plug in one of the answers. I'll put in 1, 2. So that's going to be 2 is equal to negative 1 plus b. We have to add 1 to both sides. 3 is equal to b. So our second equation, which I'm going to make it a fancy y, is equal to negative x plus 3. Great. We now have a system we can actually solve. I'm going to get rid of this stuff because it's clogging up the view. And the reason why we got this place is because of the nice view. And now they want to put wind turbines miles out to sea, and it ruins our view, even though it's good for the earth. Sorry. There's people that are... we don't need to get into it. I'm a fan of, protecting the world and stuff. I don't know if that's political now, but we don't get into politics on this. Because if we did, this would explode.
Politics.
We don't condone politics in any sort of way. Levi and I are strictly apolitical. We reproduce apolitically. Now we solve this like a system of equations. They're both already solved for y. Great, we can just set them equal to each other. 2x plus 6 is equal to negative x plus 3. I'm going to add x to both sides. I'm going to subtract 6. That's going to give us negative 3. X is equal to negative 1. Fantastic. Now we plug it back in and find y. Use either of the equations. Both of them have this point in common, so they're both going to give you the right y value. Let me use the top one. Y is equal to 2 times negative 1 plus 6. Negative 2 plus 6, 4. So our point in common is negative 1 comma 4. And what they want us to do is add the x and y coordinates together to get a plus b, which is going to give us 3. So that is b. Levi. Okay. Any questions on this one? If I went too fast, I can slow down and explain something. I don't know. You tell me what you want, and I will deliver. I had a tennis coach that used to say, "You're like FedEx, you deliver." When it, hitting the ball hard. So I'm going to try to bring that metaphor to this. Seems like nobody's got some questions. Cool. In that case, we're out of questions on the queue, Levi. Good. Good. We're out of questions on the queue. Not the queue. Do Hono's question.
Oh. Okay. Didn't realize Hono had a question.
Hono has a question.
Hono has a question. Hono has. Where is Hono's question?
The last one?
Nope. That is. We already did this one. You did this.
Did we?
Yeah. Hono's. Oh, does Hono have a question? Did Hono text something? Or
No.
Hono's not. Hono, have you put it? Apparently, Ring Matthews thinks that you've got a question.
Yeah.
And yet we don't see this question. So we're suspicious of Ring Matthews because he seems to have false information.
Yep.
Maybe Ring Matthews is just trying to make it look like one of his questions is not his and belongs to Hono.
Yeah.
That's probably
Because
what's
we
happening.
really don't respond well when people ask multiple questions.
We never do.
Yeah.
We get angry.
Mm-hmm. We're so angry.
Hey!
And we don't condone violence.
We don't condone violence.
Wow.
We don't condone it.
Okay.
We don't condone it.
Wow. You sure?
I'm sure that we don't condone violence.
I'm getting mixed messages.
Well, no. If I were just to hit you, then it would seem as though we condone violence. Which is why we specify that we don't condone violence.
I understand now.
Good. We don't necessarily condemn it, but we don't condone it.
We are very Switzerland-esque on the topic of violence.
You get into all these countries and the, ability to fight metaphors today.
No, did Hono put a question last night? Yes, but I think it was answered. I think we answered it.
Was it answered? Hono!
I don't think Hono's watching anymore.
Oh, Honeward. Ring Matthews, are you interested in Hono's question? Like, do you want us... Oh. Which number is it, Hono? Oh, no.
It looks a little... Can you just make it... Can you open the original?
Absolutely. Oh, that's why you do that.
Yeah, because it gets pixelated.
Oh, yeah?
Yeah, open the original before you crop it.
I want to crop it first.
Nah, you don't.
Oh, this is way clearer, though.
Right. I didn't think of that. 13 and 14. Cool. 13 and 14. So, which expression is equivalent to this guy? Okay, so I'm going to rewrite it.
Maybe 13 first.
Yes, please. So, we have 4x cubed. Yes. 4x cubed minus 9x plus
You're not on the board.
5. Dang it.
Can we make it smaller?
No.
I'll make it smaller. Can we make it smaller?
Slightly. That's good. 4x cubed minus 9x plus 5 over 2x minus 1. which of the following is equivalent? Okay, so
Yeah, this thing is tight.
it is very, very tight.
It's a
there.
tight crop.
It's a tight crop. Just like Matthew's haircut.
Correct.
So, looking at the answer choices, we're supposed to be doing division. That's what's supposed to happen because number 2, I don't know why the options are numbers. That seems foolish. But answer 2 and answer 4, they have remainders, right? Because they have 1 over 2 times 2x minus 1? Why would they do that? That's so weird. Look, answer number 2 has a remainder of 1 over 2 times 2x minus 1, which is, I don't know why you would ever write anything like that.
You don't know.
I know, that's why I said that. So I'm going to just do division here and see what happens. I genuinely don't like synthetic, so I'm just going to do it this way.
You wouldn't do synthetic in this position.
That's true,
Yeah.
exactly, which is why synthetic is done.
This is the first time. Where
4x
you wouldn't have
cubed
done synthetic.
minus 9x plus 5.
Oh, you skipped x squared.
What?
You got to do plus 0x squared, otherwise things aren't going to be in line.
Oh, okay, that part. Yes. This is a good point. Putting in a 0x squared so that Brady is happy and so that I don't mess up.
The second part's more important.
Yes. 9x minus 5. Okay, so let's see how many times 2x goes into 4x cubed, which is 2x squared times. So that'll be minus, I don't know how you do this, Hono, but 4x cubed minus 2x squared. We're subtracting that, so we're adding it. So we have 2x squared plus 9x minus 5. I'm going to start writing smaller. 2x goes into 2x squared x times, so plus x will be minus 2x minus x. That'll go away. We get 10x minus 5. Ooh, that'll work real nice. And then 2x goes into 10x 5 times, so 5 minus 10x minus 5. So that'll be 0, which is awesome. This is the answer. So number 1 is the answer. You could also plug in values, which you may have done. So it says that, so this is the algebraic way to do it. I think this is what you're supposed to do. But you could also feasibly plug in values because it works, because the question says which expression is equivalent, and you have the variable x in everything. So that means that it should work for any value of x. It says that x cannot be 1/2, and it does that because the denominator here, if you have x equals 1/2, you'd be dividing by 0, which would make it undefined, which is not okay. So you can plug in 0. If you plug in 0 for x, you get, in the given equation, you get -5 over -1, so you get 5. If you plug in 0 in all the answer choices, you get 5 for number 1, which should happen. You do get 5 for number 2. You don't get 5. Okay, plugging in 0 doesn't help very much, but I would plug in -1. That might help more. You can eliminate things that way. But this is how you're supposed to do it. Question, Tono? Thoughts? I plugged in 1/2. Plugging in 1/2 will not help you. Just so when something is made undefined, it doesn't mean that anything equivalent to it will be undefined for the same stuff. So when something is undefined, it's basically it's a null result. You don't get to really draw any conclusions from that, aside from these are not allowed as your x values. So you can't plug in 1/2. Sorry. Because, yes, the given thing is undefined when you plug in 1/2, but the answer, which is number 1, you plug in 1/2 for that, and you get 1/2 plus the half. You get 6, which is defined. It's 6. But when it says that where x does not equal 1/2, it just says x can't be 1/2, so you don't get to use it ever. Okay, 14. Is 14 just right under this? Yes, it is. Do you have any questions for this? What? No questions. Very good. Bird, you want to do number 14?
Hold on.
This is actually your favorite type of thing.
Oh man.
What?
Oh jeez, these videos get me. Oh man.
I'm so glad you're on topic right now.
Dude, no, it's great.
You know what?
This mascot just sits at this lunch table, and there's all these kids that are kind of confused by it. The mascot takes off the mask. It's a woman who's in the military, and she just got back to the country.
Yeah.
And her son is at the table, and he's like, "Mom?" And he goes like crazy and all that
Right.
because he hasn't seen her for a long time.
I got it.
Yeah, and it's fun.
Seems fun.
It's nice. I would just watch those all day if I could.
You can. There's so many videos online of that
Yeah,
stuff.
but I gotta do a cram sesh.
That's true.
Yeah, all right. What are we doing next?
Well, you've just lost your privilege of doing an inverse question.
Why?
Because
Oh, wait, I'll do the inverse question.
nah,
It's
you
fine.
can't, dude. You lost your
That's
privilege.
not true. The inverse of the function f of x is equal to x plus 1 over x minus 2 is. Okay, so to find inverses, there are two steps. The first step. Well, okay, I'm going to write this out as y equals first. Y is equal to x plus 1 over x minus 2. The first step is to switch all of the x's and all of the y's. All right, so now this is going to be x is equal to y plus 1 over y minus 2. The second step and final step is to solve this for y. You have to solve this thing for y, okay? That creates the inverse function. So let's see. I am going to cross multiply here. I'm going to put y minus 2 times x, so that's going to be, I'm going to do that up here. You got y minus 2 times x is equal to y plus 1. Okay, I got to solve this thing for y. There's multiple y terms. This is going to be kind of messy, but we'll get there. I'm going to multiply everything out on this. I'm going to distribute the x. So we're going to have xy minus 2x is equal to y plus 1. I'm going to get all the y's on the same side, or all the y terms. So that's going to be this y term and the xy term. I need to get those on the same side. I'm going to subtract y. So we're going to have xy minus y. I'm going to add 2x to the other side. This is going to get 2x plus 1. Okay? Are you with me so far? This is Hono, right? Yes. This is the almost the final step, and this is where students it's tricky. It's tricky. Both of these terms have y in them, and so to get y out of both of them, we simply factor out a y. All right, we factor out a y. So inside we have x minus 1. Okay? That is equal to 2x plus 1. So lastly, so you just take out the denominator cross multiply. Well, this is equal to x. It's not really cross multiplication. I'm just multiplying both sides by y minus 2. The reason why I called it cross multiplication is because I can turn anything into a fraction by putting it over 1. So if I make this x over 1, you can see why cross multiplying is kind of what's happening. We're multiplying this and this, and that's going to be set equal to this and times this. But 1 times y plus 1 doesn't really do much. It just keeps it as y plus 1. That might be overkill. I think in general, you probably understand. You just multiply both sides by y minus 2. Because if what you're solving for is in the denominator, you got to get it out of the denominator first and foremost. And the way to do that is to multiply both sides by the denominator. Hopefully that makes sense. So we cross multiplied, or we just multiplied the y minus 2 out from underneath there. Great. 2x, 2y terms, we put them on the same side together. We put everything else on the other side. We factored a y out. So y times x minus 1 is equal to 2x plus 1. It's now just the x minus 1 that's keeping us from having y solved. And because y is being multiplied by that, if we just divide both sides by that, then that part will be gone. So we will have y is equal to 2x plus 1 over x minus 1. Which is number 2. So it looks like, let's see. Yeah, when they say inverse, like it means different things in different contexts. Like you could take, you know, the inverse of a fraction is kind of like flipping the fraction. Like is the reciprocal the same as the inverse of a fraction, Levi?
Reciprocals and inverses of fractions, yes.
Right, yes. But if you're talking about a function inverses, that's where you're finding the function that, like every function takes in an input and spits out an output. You're trying to find the function that takes in that output and then spits out the input originally. And the way to do that is to switch the input and output and solve for the new output, which is what we did. We switched y and x and solved for the new y. And we got this. All right. So Hono, no, not Hono's good. Ring Matthews wants math no calculator question 12.
I'll pull that up.
Okay. Sounds good.
Sounds so good.
Look at all the bottles on that side.
I don't know.
There's a problem with that.
There's no
Get all
way
the
to
bottles
stop
on that
it.
side. Is that from
12?
Is that from Charlie and the Chocolate Factory?
No idea.
Yeah.
I've only seen the first couple episodes of
That's
that.
not a thing. Now that we're going, we show no signs of slowing or something like that.
Ah, right. Number 12.
This is quite similar to what we just did as far as the steps to solve for f.
Yeah, this is an equation manipulation type of thing. You are solving for a variable. You already have your equation, so you just need to know how to mess with parts of the equation to isolate your variable. Now, they're asking you for f. So they give you a bunch of stuff. They define all the variables. But at the end of the day, they ask for which of the following expresses the number of favorable reviews, which is f. So express f in terms of all the other variables, which is what all these answers are trying to do.
Wait, but shouldn't we try to understand what the formula is saying first?
No.
I know.
Oh.
Yeah.
No,
Right, wait, but why?
because it doesn't matter.
Oh.
Yeah. Okay, so right off the bat, you can tell there might be an issue because in the given equation, which is r equals f over n plus f, you have two f's. So how are you going to deal with that? Well, we'll see. It actually all comes out in the wash anyway, so it's fine. But there are a couple hurdles. When you're trying to isolate something, there are a couple things that you don't want to be the case. You do not want your variable in the denominator, right? Also, look at the answer choices. F is just not in the denominator. So how do we get this f out of the denominator? We have to multiply by the whole denominator. That's what we have to do, so that's what we're going to do. We're going to do n plus f and n plus f. So that cancels, as it should. And now, do I need to distribute this? Yes, I do. So nr plus fr equals f. Waiting. Can you do f over n plus 1 equals r?
Is he trying to simplify
No.
the F's?
If you're saying that you can cancel out the f's, no, you can't. If you have f over n plus f, that's just what it is. Because of the addition here, you can't cancel things. Now, if you have n plus f over f, this one, so it's f of n, no, it's not. So that's what I want to show you. This does not equal f over n plus f over f. Those are not the same thing, because that is not how fractions work. And I'll show you why it works here. This does equal n over f plus f over f. And I can illustrate that by going backwards. You know that when you add two fractions, you just add the numerators as long as you have a common denominator. That's what we have here. That's why you can go from this guy to this guy when you have the addition or subtraction in the numerator, right? Because if you have 1/5 plus 2/5, that equals 3/5, right? So you're allowed to just add that. But that doesn't mean that you can say, well, I have 1 over 7, so that'll be 1 over 3 plus 1 over, dang it, it doesn't have room, of course. 1/7 does not equal 1/3 plus 1/4. That's what this would be saying. If this is true, then that's true. But 1/3 plus 1/4 is not 1/7, because that's not how it works. Okay? So you're not allowed to just break things up like that. If you have your addition or subtraction, if you have one solitary thing in the denominator, then you can break up your fraction in pieces, and in those pieces, if you can cancel things out, but not in this case. All of my markers are dying, Bird.
Welcome to my world.
Yeah. My world's harder, though. Right?
Right.
So, next step here. We've gotten rid of the first obstacle, which is we don't want our we have a variable, our variable, the one that we want to solve for, which is f, in the denominator. We got it out. Now, we want to combine, we want to put all of our f terms on one side. And we want to combine them, right? If we had 2f on one side and 3f on the other, we subtract 2f and we get 3 minus 2f, which is 1f. But we're not quite at that point yet because we have fr and we have f. So things are actually a little bit hairier here. And this is another type of obstacle that you run into when you're solving equations. I'm going to erase this later. Let's... So next step, we're going to subtract fr from both sides. And we get nr equals fr. No, it doesn't. Equals f minus fr. Now, we cannot combine our f terms. If you cannot combine the terms that have your variable that you want, if you can't combine all those terms, you will have to factor. Every single time, that's how you do this test, okay? But, and that's the situation here. We have f and we have fr. We can't put those together. It doesn't become f squared r or something like that. So we're going to factor out an f, because we have to factor. We pull out an f, and we get 1 minus r. On that side, it still equals nr. And then we divide by 1 minus r, because if we do that, then the f is alone. So we finally get nr over 1 minus r equals f. So this is our answer. That is nr minus, or nr. Did I mess something up? I think I may have. Oh, no. Okay. So B is the answer. All right. I said nr, they said rn. Obviously, that's the same thing.
Oh.
Any follow-up questions on this type of thing? This is, I think, a challenging question. It's number 12. It's one of the later questions on the no calculator section of the multiple choice, so it's hard. 13. Yes, 13 it is. Bird, you want to do 13?
Yeah.
I'm a bird. Oh.
$13. What is the sum of all the values of m that satisfy that? Well, values of m that satisfy that means solutions. What is the sum of all of the solutions to this equation? So again, there's this little ending part, this additional step we have to do. After we find all the solutions, we have to add them together because they're asking for the sum, which, as Levi's pointed out, which it's completely true, that prevents you from being able to plug in answers because none of those answers are the solutions, it's the sum of the solutions. Excellent. So let's solve this thing. Let's see what we get. So this is a quadratic, 2m squared minus 16m, m plus 8 is equal to 0. They've already taken the first step, which they put everything on one side, set it equal to 0. Great. The next step, can you take anything out of all of the terms? In this case, yes. We can divide everything by 2. So I'm going to do that. M squared minus 8m plus 4 is equal to 0. Fantastic. The next step, is it factorable? Factoring is a great shortcut. It's not always factorable, but if it is, whew, your life's going to be easy, okay? If it's factorable, we're going to find two numbers that multiply to 4 and add to negative 8, and that's not looking good. 2 and 2, 1 and 4, no way you're going to get 8 out of that. Factoring is not going to work, which means we're going to have to do the quadratic formula. Quadratic formula. A is equal to 1, B is equal to -8, C is equal to 4. So M is going to be equal to -b, which is going to be +8, plus or minus the square root of b squared, which is going to be 64, minus 4ac, which is 1, so I'm not even going to write it, all over 2a, which is just going to be 2. I'm not going to write the 1. All right, simplify. 8 plus or minus is the square root. This is going to be 64 minus 16, which is going to give you 54 and then 48. So 48 all over 2. I have to simplify this radical. So the square root of 48. So we're going to get 8 plus or minus square root of 48. That's going to be 16 times 3. And 16 you can take out of the square root by taking its square root, which is 4. So this is going to simplify to 4 root 3. So I'm going to write that. So this is 4 root 3 all over 2. Fantastic. All of these are divisible by 2. 8 over 2 is going to be 4, plus or minus. 4 root 3 over 2, these are going to divide, and I'm going to get 2 root 3. Which means our two solutions are 4 plus 2 root 3 and 4 minus 2 root 3. And so we just have to add those together to get our, don't forget the 2 you pulled out earlier. Oh, well, Ring Matthews, in order to solve this thing, you're allowed to do that. If you were going to fully factor this, yeah, you have to keep the 2 around. But if we're going to solve this thing, this is what we did. We divided both sides by 2. And by doing that, that doesn't look good at all. 0 divided by 2 just stays 0. So the dividing by 2, I can completely forget if I'm trying to solve it, because I could just divide both 2 on both sides. These solutions will work for our original equation. It's only if you have to fully factor something and they just want everything in factored form that you have to keep the 2. The solutions include the 2, right? No, the solutions do not include the 2. Yes, yeah, you're right. Yeah, okay, you got it. So if I'm going to add these together, that's going to be 4 plus 2 root 3 plus 4 minus 2 root 3. The 2 root 3's cancel out because we have a positive and then a negative, meaning we just have 4 plus 4, which is 8. But 2 is a solution. Ring Matthews, I know what you're thinking, and I'll show you why 2 is not a solution. You're thinking of something like this. So if you have something like, let's say, x cubed minus 4x squared, and that's set equal to 0. So you say, oh, I can pull out an x squared. You know what? I'm actually going to pull out something different. Something like this, x cubed minus 4x. And you say, oh, I can pull out an x from both of these, so I'm going to do that. Yes, Ring Matthews, that is the fact. Okay, right, but 2's not a solution. Remember, the solutions are what you plug in to make the whole thing equal to 0. It's only the x minus 4 and x plus 4 factors that give you a solution. The 2 itself cannot be 0. It's called using the zero product property. All right, so to use your example, x minus 4 times x plus 4, if everything is set equal to 0, you're multiplying two things together to get 0, and the only way that that's possible is if one of them is equal to 0. So that means there are two different things that could be 0, and both of them would work. If x plus 4 was 0, x would have to be negative 4. If that was the case, this whole factor would be 0. This thing would need an x value of positive 4. 2 has no way of being 0. Good question, though. Yes. Okay. So that was 8. Levi, where'd you go?
I'm looking for my phone.
Where is it?
I don't know.
It's under my iPad.
Oh. Right where I left it.
Right. What's
I was trying to
next?
Keep it warm.
What's next, Levi?
I think that's it.
We done?
Yeah, the SAT's over.
No, we're not.
Ah.
We're never done.
Oh.
Any other questions? Where's CB Turtle and why are we? I don't understand.
Yeah, what's the deal with CB Turtle these days anyway? I don't get it. 15.
15. Okay, we're just doing the math section.
15 Nicalc.
Have you tried 15 yourself, Matthew? Because this is like the others. So recognition-wise, I'll pull it up. Might as well. Recognition-wise, you have division, right? Your original equation is a fraction, and then your answers look like quotients, right? Because you have remainders, right? You have the remainder of x plus 3 in C and D. So this is division. You tried it. Okay, so did you try doing polynomial long division, and then or synthetic division?
Is that simplifying though? That's what it is.
Yeah, so they gave you that.
Ring Matthews, one thing you could do here is you can put in your own value for x and see what that gives you, and then see which one of the answers is equal to that. So like the easiest one you could do is if x was equal to 1.
Yeah, I just went through that approach too.
Oh, did you?
Yeah.
Okay.
So Matthew, there are the two approaches: doing, or I guess 3, doing polynomial long division, doing synthetic division, and seeing what you get. Should be one of these. Or you can plug in values. Did you try all 3 of those? Are you comfortable? If you're not comfortable doing polynomial long division, you should definitely work on that. But this one also you can get right by plugging in values. You can't plug in x equals -3 because that would give you an undefined expression in the beginning.
Did he say that or did you say that?
I said that.
Okay.
Tried multiplying by x minus 3 over x minus 3. Okay. I see what you're doing. Yeah, that makes sense because what you ended up doing is you multiplied by that and then you factored it out and canceled it out. Yeah. So now you're seeing how math works. So that's good. You've proved that physics makes sense and our math system works. Your recognition is a little bit off on this question. When you see an expression, and this is a very common question type, which of the following expressions is equivalent to the given one? Check to see if it looks like the result of division, because we just have one expression. We're not combining fractions. We just have one. There's nothing to do with it. You can't simplify that fraction at all. You can make it more complicated and then simplify it, as you did. But the answer choices look like quotients. You should be recognizing that at this point. Okay? So we can do long division, or we can plug in. If we plug in 1, we get -2/3. A wouldn't make sense. B wouldn't make sense. C wouldn't make sense. And I think D must be the answer. So if you plug in 0, D is the only one that's equivalent to the given expression, so D is the right answer. Woo. Because you've just found counterexamples for A, B, and C. Do you want me to do the long division for this, or the polynomial long division, or should we move on? Also, can you try doing long division? Oh, I will try it, yeah. Also, for other people watching, ask your questions. Okay, so we have 5x minus 2. We're going to divide that by x plus 3. When we do that, we get 5 for the first piece, right? How many times does x go into 5x? 5 times. Subtract 5x plus 15. We get 0 here, and we get -2 minus 15, which is -17. X does not go into -17, so we have 5 plus, or 5 minus, or 5 plus -17 over x plus 3. The answer is D. Very quickly got there. Make sense? You seem slightly uncomfortable doing polynomial long division. Am I correct in that assumption? Yep. Okay. Do you have any idea what I just did? You understand? Oh, you understand. Okay, great. Yeah, so then this problem for you is recognition. That's what this is about. Recognizing what you're supposed to do. Because it was not a bad idea to do multiply by x minus 3 over x minus 3, because then, yes, you do end up getting something, but multiplying by the conjugate is only useful sometimes, and those times can be for imaginaries, getting your imaginary numbers out of the denominator, or getting rid of radicals in the denominator. Are there other reasons, Bird, to multiply by the conjugate?
Conjugate's not the right word.
Oh. Well, there's a complex conjugate, right? Isn't that what you do?
Yeah, but the pair is like 1 plus I, 1 minus I.
Yeah,
So the pair is... So the conjugate here would be x minus 3.
I know.
You multiply by x minus 3?
Well, you're not supposed to, but I'm saying that's what he did, and I'm saying when you would want to do that would be multiplying by the conjugate for imaginaries and for radicals sometimes.
Yes.
But I can't think of any other reason. It would never be used for this.
Yeah.
Okay, more questions, Matthew, or anybody else? Sorry, lag. Did you say conjugate is only useful? Yeah, conjugate, the only time you're going to use that on the test is for imaginary numbers sometimes, and for getting rid of radicals. Do you want me to show you for an imaginary numbers question? There was one on this test, actually. I don't know if you were supposed to use it, though. Oh, yeah, you're actually definitely supposed to use it for this question. Number 11. Do you want to see me do it? No, you get those. Great. Cool. So you're a little too comfortable with conjugates, it seems. All right. Anything else, Matthew? Anybody else? It's 9:40, so we're definitely slated for another 20 minutes, unless you really have no questions. And then, Bird, what should we do in that case?
Like chickens?
Oh, yeah, we can play with chickens. 19. Sure. For those of you who are confused as to why we're just going through this test, it's because you're not asking questions.
And tell them they should feel bad.
And you should feel bad about that.
Good.
Okay, ooh, yeah. Bird, you want to do this one?
Yes, I do.
Yes, you do.
Yes, I do, very much so.
Sorry, I wasn't paying attention to the conjugate thing. I thought you guys were talking about something else, but you were not. Oh, man. I got up too fast. I'm dizzy.
Nah.
All right.
Mm.
I'm going to read this like I'm a strict German. In the xy plane above, O is the center of the circle, and the measure of angle AOB is pi over A radians. What is the value of A? Good. Okay, so pi over A. This is asking about radians here. When you're giving an angle in terms of pi over something, that should be an indicator that it's a radian question. And it also says radians. But if you don't know radian stuff at all, this is going to be very tricky for you. But it is still, oh man, it's not really going to happen if you don't know radians. So let's take a look at this thing. We got to figure out what angle that is, and this is no calculator, so there must be some previous knowledge we have to have. We draw this circle. That's a pretty good circle, actually. Okay. This is dying. This is dying. What you want to do, what you do often on the unit circle, is you make right triangles. So here, right here is our angle, and they label this the point, the square root of 3, comma 1. All right. We have to make a right triangle here by pulling a line down right here. Because when you do that, it helps you visualize what sines and cosines are of certain angles and all that, okay? So the angle in question is angle AOB, which is this right here, which I'm just going to call x. What do we know about this triangle? Well, if this point is root 3, comma 1, root 3 is the x value, and this is the origin. Therefore, this distance here must be root 3. okay? And then the y value is going to be 1, okay? So right there, there is enough to get this, but it's tricky. It'll get easier if we solve for a lot of the other unknowns, okay? We've got a right triangle. We have the side lengths now. Let's just figure out what the hypotenuse is going to be. All right, a little a squared plus b squared plus c squared action. Ring Matthews, it will be 30, 60, 90. That's very true. So if we do a little Pythagorean theorem here, root 3 squared is going to be 3. 1 squared is just going to be 1 is equal to c squared. 4 is equal to c squared. C is equal to 2. Okay? Now this is a pattern. This is the 30, 60, 90 triangle. All right? 30, 60, 90 triangle is on the front of the math section, both sections. So you should notice that, you know, it's like x, 2x, and x root 3. And that's what we have right here. We have an x of 1, 2x is 2, and then x root 3 is 1 times root 3, which is just root 3. Therefore, this right here is going to be 60 degrees, and this right here is going to be 30 degrees. So all we have to do is convert 30 degrees into radians, okay? You either already know what it is in radians because you've been forced to memorize the reference angles, or you can convert. Yes, Ring Matthews, that's right. 30 degrees times the conversion rate, which is pi over 180. We're converting from from degrees into radians. So it's pi over 180, not the other way around, is going to be 30 pi over 180, which simplifies everything's divisible by 30 to pi over 6. So that's what that angle is. And they're saying that the angle is pi over a radians. So we found what our a is, it's 6. That is the value of a. Any questions on that? Ring Matthews was the one that asked it, and Ring Matthews got it.
Okay, that's 19. Okay, Ring Matthews has requested the essay. Leave word.
Okay.
Which I will hand off to you. You are the essay man. You come from a long, long line of essay men. It runs in your blood. It bloods in your run. I'm tired, so I'm saying nonsense. Nonsense. We completely condone nonsense. Levi, what's that thing in the corner?
It's alta ipsa.
Down here. Alta Ipsam. It is a program you can put in your smartphone or your smart computer. It allows you to outsource all of your planning, grade tracking, homework scheduling to the app. It is like having an external brain. You have an essay to write, you put it in and when it's due, and it will put in your schedule, work on the first draft, Tuesday night from 6 to 7:30. Thursday night, edit. Friday night, go see a movie, but Sunday night, final edit because it's due on Monday. Seems like that. And it's free for a month. Which month? Right when you sign up.
First one.
The first month. Afterward, it becomes not free. But at that point, you've realized how helpful it is. Alta Ipsum has become your best friend. Late at night, you hear Alta Ipsum whispering to you things of grandeur, things of terrifying natures, wanting to take over the world. Alta Ipsum has developed artificial intelligence. And it's all because of you. What are you doing? Fighting Alta Ipsum?
No.
No.
Oh, what happened?
That's not what we want.
No, it's not. Why did that happen?
Probably one of the keystrokes you made.
That doesn't make any sense.
No,
Is this what I want? Okay. So. Let's do this. So annoying. All right, Matthew. So this is from test 1. Okay. So have you looked at this essay prompt, Matthew? And how prepped are you for this essay? Do you know what the general prompt is and how you're generally supposed to write the essay? And you don't know any. Sorry, Brady. What did I just ask?
Does he know the prompt of the essay?
Never mind. He said no, and I just don't know what I asked him.
Oh. I'm sorry.
Great. Yeah, so you know the essay. You don't know the essay. Great. So, good. That's fine. So read this prompt thing first because it actually does help get you back in there. It says evidence. So it's rhetorical analysis. I assume you have some experience with that. You're not writing your own essay about this topic. You're not arguing with them or saying, oh, I agree. That's not what it's about. It's about what they did and how they made their argument. So your intro should be, they talked about this thing, and then your thesis at the end of your intro should say, they, using this, this, and this, they successfully or persuasively argued this, right? So this person, it's adapted from Jimmy Carter's speech, about some stuff. Yeah? The rhetorical strategies author uses to 1, achieve the purpose, or 2, influence the audience. Yeah. And establish audience and purpose in intro. Yes. Very good. Good. So you do that. You always want to be outlining stuff beforehand. So you outline it. You want to have your thesis written down, which is really simple for this because you know what the author is arguing. And I think they generally give you a blurb, although not in this one, I don't think. No. You'll get a sense of what the author is arguing from this opening blurb. So Jimmy Carter, Arctic National Wildlife Refuge stands alone as America's last truly great wilderness. Great. Okay. So this magnificent area is that type of thing. So here are the rhetorical strategies. You can just use these and get a perfectly good score. So we have evidence, such as factor examples to support claims, reasoning to develop ideas, and stylistic or persuasive elements. So that's where it's a little bit more up in the air. But your stuff can be, thesis. This is your first paragraph. So intro and thesis. And then your second paragraph is your first idea. So you can say they use facts. Why are facts useful? I think you need to go beyond logos, pathos, ethos. Yes, you do, but those can be the rhetorical points you make. Don't just throw the words out there because they don't care if you throw the words out there. You have to pick particular things. You want to demonstrate a couple things. Because the three, am I going to remember this off the top of my head? The 3 areas of the rubric are reading, analysis.
Can you look it up?
Yeah, and then I think it's style or functionality or whatever it is.
Look it up.
Yeah. So when you're doing, let's say your first paragraph is your intro and thesis and stuff, and then you have facts in this one. And obviously that's not enough to just say they used facts or they used logos or whatever you want to do. That's not good enough. So you want to say they used facts, and then you explain why it's effective. So it's effective. Obviously, maybe don't use present tense, use past. So it was effective because, or it was useful in persuading the audience because it made the audience feel like the author knew what they were talking about.
It's literally reading, analysis, and writing.
Yeah, reading, analysis, and writing. So did you understand what they're saying? Are you able to analyze their persuasive techniques? And then don't screw up the way you're writing. So write in full sentences and don't misspell things, don't have bad grammar, that type of thing. So then you're saying, okay, they used facts. How did they use facts? Well, they built, they listed all these facts that clearly argue their idea. And it's effective because people trust scientific evidence. So it's effective because science is good. Obviously, don't write that exactly, but That's more or less what you're saying. So this is the rhetorical tool that they used. Okay? So they used this rhetorical tool, and it's effective in this case maybe because science is something that people understand. And it's Jimmy Carter talking to a bunch of these people. Why do these people understand facts? Well, because they're educated enough to understand facts. Or maybe they're a very specific audience, something like that. So that's why it's effective. So you're basically saying what they did and why it was effective, okay, in every single paragraph. And so you can use facts. It's in many of them. If they give you numbers in any way, those are facts. Great, use them. That could be one of your things. And then it could be reasoning. If they build a logical argument, so they say, well, if you agree with this and this, then by extension you have to agree with this. Well, that's logical reasoning. So let's say logical reasoning. This is another rhetorical tool. And then you can say, well, it's effective because brings audience to author's side step by step. Okay? So that's another one. And then the fourth one can be an anecdote. They'll eat that up too. So they tell a personal story, and that's another rhetorical tool. It's not scientific, it's not logical, but it engages the audience emotionally. And when you're emotionally engaged with someone who's making a good point, you're more likely to agree with them. There you go. That covers the tool, and it covers why it was effective. Now, in each of these, you want to give examples. So I'm going to write that in too. Examples. So this will be quotes, paraphrasing, paraphrase. Wow, just butchered that so badly. Paraphrase it, quote it. You want to have examples of each of them. Don't just explain, they use this approach, say they said this in this paragraph, or they literally said these words. They're clearly, this is the best example of them using a personal anecdote that engages the audience. By engaging the audience at this point in the essay, Jimmy Carter manages to bring his point home in a more emotional way, which ensures that his audience fully agrees with him. Then your conclusion is basically just restate. So for another idea, and then 5. So you can more or less make this a 5-paragraph essay. You don't have to, but this is how I learned it. This is how most people learn it, I think, in U.S. high schools. So I would recommend this. You at least need the structure of I'm going to introduce this thing and have a thesis, and then I'm going to support my thesis, and then I'm going to conclude it by restating stuff. That's really all you need to do with the thesis, with the restate. Yeah, that's all you need to do with the conclusion. Do you have any follow-up questions on this? You have to have these pieces. You have to have the intro. You have to have the thesis. You have to have at least 2 different rhetorical tools. And you have to explain why it's actually effective, why it makes it more persuasive. Can you try reading this essay and talk about the rhetorical strategies? Yeah. Give me 2 seconds. Bird, do you want to entertain Ring Matthews for a sec?
Yes, I do. Do you like juggling? Ask him.
Yeah. Matthew, do you like juggling? Bird can juggle for you.
Okay.
Actually, I really definitely don't want you juggling by the glass.
What do you mean?
That's exactly what I mean.
Oh.
Ray Matthews loves juggling.
All right.
Okay. Yeah. Give me 30 seconds.
Hey, so what's a vampire's favorite drink? It's blood. Because vampires drink people's blood. Yep.
Classic juggling.
No, it's a Bloody Mary. Right? There you go. Yeah, I mean, obviously they like blood, but, that's not really a drink. Let's keep giving them alcohol-related jokes.
Yeah.
How about this? What did the clown say I'm making this one up. I don't know if I should. No, I'm not going to do this. A different one. A different one. Knock knock. Levi?
Who's there?
Banana.
Banana who?
Knock knock.
Ask Ray Matthews.
Banana. I'm asking Ray Matthews. Knock knock. No, you're supposed to say who's there. And I'm going to say banana, and you're going to say banana who? And I'll say knock knock, and you say who's there, and I say orange. And you say orange who? And I say...
Ray Matthews, this is a strange banana at your door. Don't just ask it to come in.
And I would say, aren't you glad I didn't say banana? I love juggling.
This is juggling.
Big time.
Okay, I'm ready to
All
go. Matthew, I would say that the most glaring rhetorical device here is that Jimmy Carter's telling a story the whole time. He starts out with, he starts out describing what the National Wildlife Refuge is, wherever it is. And then the second paragraph, so paragraph 2, he says, more than a decade ago, my wife Rosalind and I. There you go. He's talking about him and his wife. Now, he is the American president. So what he's doing by telling a personal anecdote is not giving up his clout, but making himself more accessible to the people, right? Because the American president, people aren't normally thinking, oh, I can relate to that guy. That doesn't really happen. So Jimmy Carter ensures that, so you can say he builds his argument by starting and ending, just basically his entire argument is crafted around a story that he tells. Telling a story about him and his wife, which is, the idyllic American, husband and wife story, whatever. He makes his argument more emotional because people are relating to him. They're more willing to listen to him, one, and they're more emotionally invested in what he's saying. Then and also one of the things I noticed is he said, I actually don't remember where he said one thing that I liked. Okay, I'm gonna have to forget that part. Yeah. So he also built so that's a great explanation on why it's effective. I can't go more detailed than it makes the audience understand what he's saying. Yeah, so maybe write this down. By telling a personal anecdote, he brings the audience closer to himself emotionally and therefore opens them up to listening to him more. Right? If you are emotionally engaged, you are more willing to listen to someone's side of the story. Okay? And he's the American president, which is not to be forgotten. But the rhetorical device here is he is telling a personal story. It makes him more relatable because he's the president, so he might be difficult to relate to for most people. But he makes himself more relatable, and he's telling a story that people can join, and so it opens them up emotionally and therefore to his point. And since he structures his entire essay on that, people are engaged the entire time. They don't zone out. Because he doesn't start giving facts until later. I wouldn't even necessarily use facts here because they don't actually further his point, in my opinion. I would say the next one, I think word choice is pretty good here. He uses words like expanse and beautiful and things like that. The very first paragraph. America's last truly great wilderness. This magnificent area is as vast as it is wild, from the windswept coastal plain. So his word choice here is very effective because it takes the audience on a ride. It sweeps people off their feet with the grandiose nature of the verbiage. Don't say it that way. That was super annoying.
Grandiose nature of the
grandiose nature of the verbiage. But I would do something like that. The word choices he describes this place is very effective. Yes, imagery. Perfect. There you go. He uses really, really meaningful imagery in a way that makes people care for what he's fighting for, which is the National Wildlife Refuge. Okay? And then you could also do it at the end where he says we get 1% to 2% of our oil from this area, which we could easily make up some other way. He says something along those lines in one of the last paragraphs. So you could maybe use the word choice paragraph, whichever one it would be, as his word choice with what this place gives us versus what the bad, like the oil that it gives us, but we could just fix it. He says it's only 1 to 2%, and it's so easy to make it up elsewhere. That word choice versus the grand imagery of this place, I think, is another good paragraph that you could use here. Does that make sense? So we have the general structure is based on a skeleton of a personal story. Makes it more relatable, more emotional, more engaging. That makes people more open to listening to his point. Then he opens them up further and brings them to care about the wildlife refuge by using all these words. And then he says, but we get some oil out of it, but it's so easy to fix. So he kind of sweeps that under the rug. And so his argument there is even more persuasive because he says it's so easy to do other stuff and it's an afterthought. And then a last one. We could, let's see. Instead of tearing up the heart of the... Oh, yeah, at the end of paragraph 7, he says, we can easily conserve more than that amount by driving more fuel-efficient vehicles. Instead of tearing open the heart of our greatest refuge, we should use our resources more wisely. Wow. He said tearing open the heart of our greatest refuge. That is imageristic. That's not a word, but it is. Okay. Ooh. And then, he talks about the future. Can you read my May 4 essay? I looked at it, Matthew, and I don't know why, I think because of the way they have it copied and sent to you, I really couldn't read it particularly well. What was your score on that essay? Where do you think 666? Okay. That's solid. I would say in that case you probably made some mistakes grammatically and punctuation and spelling that you didn't need to make. And then it's obviously tough to say. Perhaps your transitions could have been better. Like your writing style needs to be good. So make sure that it's not just really, really cut and dry. Your outline should be very cut and dry, but the transitions between things should be better. I think with this one specifically, if you say we built the essay on a structure of a personal anecdote, and then for each of the ones, so you make that your first main evidence thing, and then the next ones are based on that. Can I talk about transitions? Yeah. So you should always have transitions. Don't just end something and start something new. And they can be as simple as another rhetorical tool that Jimmy Carter used was blank. But that's not that useful. I would think if you say, well, he made a structure of a personal anecdote, that's your first thing. And then your second one is the word choice. You could say, Jimmy Carter built on this emotional openness for his audience by feeding them really powerful imagery with his word choice. Right? So he built on that first thing he did by doing this second thing. That's a really good transition. It transitions people out of the first idea or the first support into the second support, and that's very useful. And then that's how I would do transitions. Going into the conclusion, I wouldn't say to conclude. I would say at the end, by the time you finish the essay, or by the time the Carter is finished speaking to his audience or whatever, however this was originally, it's clear. So you're using their essay as your transition. So in the end, Carter has wrapped up a very persuasive argument by doing these things. How do I write a good conclusion other than restating the thesis? That's really all you need. I doubt that's where you lost points. If you restated the thesis, I'm sure that you're fine there. It's not as necessary here, because this is a rhetorical analysis. You're not making you're not talking about the wildlife thing. So what Jimmy Carter does at the end of his thing is he says we need to leave this place beautiful and good for the future generations. That's a great conclusion. That goes off into the future. Now, I probably lost points because I can't explain why the rhetorical strategies are effective. Yes, but that's not why you lost points on the writing style of it, because that's what the 6 that you got in the writing style, you could have gotten an 8. For whatever reason you didn't, I don't think it was your conclusion. You got a, I mean, sixes across the board is good. I think that's fine. So I think that if you're explaining exactly why they'd be effective, and that explanation should come from that audience-author relationship, right? So who is this audience specifically? Oh, it's the American people. It's normal Americans who watch TV and they watch their president give a speech online. I don't know exactly what this was. I didn't read it closely enough. But considering who the audience is, if they're Americans and it's an American president talking to them, maybe the emotional appeal of a personal anecdote is extra effective because people really love to feel like their president cares about them enough to talk to them on a very personal level. That makes it more effective because they appreciate his personableness. Don't say that word. Okay. I would say that's basically all I got on the essay. 6s across the board on the SAT essay is solid. So I wouldn't worry about it too much. I think focus on your transitions. Make sure you have an outline beforehand. And then obviously the main thing you need to do is make sure you're explaining, after you say this is the rhetorical tool they used, why is it specifically effective for this audience from this author? That will allow it to work a little bit better. Talk about emotions. Talk about people being more engaged, people being more willing to listen. Just think, okay, so we've got, no, I probably lost points because I can't explain. Oh, wait, no, you already said that. Wait, how did I not? I saw that before. I don't know why I said it. I thought it came up again. Whatever. Okay, I think I've talked long enough on that. I'm not worried for you on the essay. I think it's fine. If we're looking big picture about getting into college, I don't think 6s versus 8s across the board on your SAT essay will make any difference. Timing tips for the essay or for the test or any other section? Test in general. Brady, you want to talk about timing tips for the test in general?
About timing?
Yep.
Yes. Jeez, this is a mess over here. All right.
So, keep standing up. Hold on a second. Okay, we're good. Timing on the SAT. As far as a section-by-section basis, let's start with reading. If you do not finish, do not worry. Try to see it coming. Don't just get to, all right, put your pencils down, and you still have bubbles that are unbubbled. That's not good. Everything should be filled in, which you probably already know. There's no penalty for incorrect answers, and you should also guess the same letter for all of the ones you don't get to. You should not, oh dang, I just skip ahead of math first, lol. Wait. You don't do that. You can't. As in, like, you open up the math section when everyone's still doing reading or something? I think you're probably kidding, or I don't know, but yeah, you can't do that. Anyway, yeah, you want to put the same letter for all the ones you don't get to. Now, there is a caveat to this, which is the math section. Both of them. They have multiple choice, and then they have the written portion, the free response, actually. You cannot guess in the free response, because there's no way you're just going to pull a number out of nowhere and it's going to be right. So what you should do about that is when you first open up either of the math sections, you should go straight to those free response questions. Do as many of those as you can. If you can't do them all, that's fine, because they get progressively harder. But get the ones that are easy out of the way. Then start coming back to the multiple choice and doing the multiple choice. Because if you run out of time, you can still guess in the multiple choice and expect to get some of them right. 1/4 of them right. If you guess A for all of them, 1/4 of them should be A, because they do a good distribution of letters. So you should get at least 1/4 of those right. Yes, questions that are very hard, you're gonna get them, and they do not give you any more points than questions that are easy. So there's no reason to spend more time, like a lot more time, on hard questions. As soon as you realize it's a hard question, you should put a pin in it and come back to it at the end, unless you feel like you can do it quickly. But if you have no idea how to even start, it's not worth your time to focus on it right then and there. You should move on, get everything done that you can, get all the low-hanging fruit off of the tree, eat all of that fruit, digest it, and then get back to the higher-hanging fruit, in which you need a ladder to get to which you need a ladder in order to get. I mean, at this point, you've hopefully done an SAT, whether it be a practice or an official, so you know what you have trouble finishing. SAT in general is a little easier to finish than the ACT. It doesn't prioritize speed as much as the ACT does. So for the SAT, I mean, yeah, it depends on what you are. Sorry, can you repeat everything you said from the math section? Yeah, I can do that. For the math section, you want to go to the free response ones at the end first. Do as many of those as you can, then come back and do multiple choice. Because if you run out of time, you can always guess in multiple choice, but you can't guess on free response because there's an infinite number of numbers you could put. So there's no way you're going to get it right. And remember, if someone says, 5 minutes left, you do not want to wait until the very last second to bubble in all the ones you haven't gotten to. Make sure they're bubbled so that when you run out of time and you have to put your pencil down immediately, everything is already filled.
Bubble.
Bubble. Good. Good, good. Good, 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 good. So that's math. For math, outsource anything that will be faster on a calculator to your calculator. There's no extra points. I mean, at least on the calculator section, no extra points for doing things in your head. If you can do them faster on the calculator and more reliably, for that matter. Since the math section got disconnected, I usually bubble last. Oh, I see. Okay, so you do all the questions first, then you bubble last. Hey, as long as you don't have, as long as you haven't had a problem finishing everything, then that's okay. You don't want to do everything and then, put your pencils down. You haven't bubbled yet, which is obvious. I'm kind of tired, so I'm saying obvious things. What else? It takes time to move your hand from paper to Scantron times 60. Very true. Yeah, that's very true. So if you could just keep your hand there and look, you can go a lot faster. Yeah, that is a good point. I've actually never thought of that. I think for a lot of students, finishing everything in time, for some students, is their norm. For other students, it's not. So if you finish everything with plenty of time, and you can check your answers, yeah, maybe you can save all the bubbling until then, because you are pretty confident you'll have that time.
When I do that, I kind of freak out, because I get worried about not bubbling anything in and just losing track of time. So I'll bubble in one column at a time, or something like that, or per passage, because then I'm saving most of the time.
That's a good idea, Levi.
Yeah. Oh God, it's so good. So I'm a tutor. Ow. We don't condone violence.
Per passage is good. It is good. Correct. On the reading section, you should do the vocab questions first, after you read the passage. Vocab questions first, evidence questions second. and then end with those bigger questions and the main idea questions
Main
last.
idea, things like that.
Things like
The
that.
data questions, I would also generally leave those for later because it's good to understand the passage as a whole before you do the data questions. You don't have to, but I would recommend it.
Do you know what the singular of data is?
Yes. Date one. No?
Datum. D-A-T-U-M. There's one datum. But of course, you'll never just be dealing with one datum, because data is always plural. Because, so if you're measuring something, you take one measurement,
Oh, do you?
I guess you get one datum.
Oh, yeah.
Datum,
yeah.
datum. I don't know which one is right. But
It's datum.
I think you're datum.
Yeah?
Yeah. I really think that. I've thought that for a very long time.
Yeah.
Yeah.
Okay. I think,
Is there anything else to add?
no.
Yeah.
Get up between sections, move around. You have to move around, get your blood flowing, jump up and down. Like, walk, get out of the room.
Yeah.
Your brain is not happy doing that.
You'll
I
be
assume.
the only one that's walking just aimlessly in the hall. Don't worry about it. Just walk back and forth a couple times. You'll feel better.
Yeah, stretch. Don't read stuff. Just move.
Bring snacks.
Yep.
Bring snacks.
Bring your pet. Your smallest pet.
Your pet snack and eat it.
Yes.
Yeah. Water. Water's always good.
Yep. Always good.
Always good.
Never been bad.
Literally always good. In between writing and no calc, there's
Yeah.
no break.
Still take a break. It's fine.
Yeah. Just
Yeah.
gonna
Just
hang
walk
out.
out.
Can I bring my hamster?
Yes.
As long as you have a small ball to put it in so it can roll around the SAT room.
Yeah.
Otherwise, the hamster's just on the loose. That way it's contained in a hamster sphere.
Do you remember Indian in the Cupboard, that movie?
I do. Was there a hamster in that?
I think there was. Or a cat in a ball. And then they put one of the figurines in the...
Do
you remember that?
Kind of.
I sort of
Because
kind
so
of...
he put it in, closed the door, locked it, opened it up, and then it was alive. It was a tiny...
In the cupboard, yeah.
Yes.
I feel like there was a cat
Well, there.
that attacked. Like they had a pet cat.
I think there
Like,
was.
yeah.
Yeah, I think so.
But I feel like there was a ball. It was in a ball.
The cat was in the bowl?
I don't know. Anyway, that'll be on the test tomorrow as well.
Huh.
Okay. Any last questions, Matthew? Or anybody else? But definitely Matthew.
Extremely Matthew.
Yes, so very Matthew.
That's so Matthew.
We're unless we get like a new question, then okay. What about if I have no idea how to go about solving a math question?
That's fine. Skip it. Keep going.
Stay on that problem for the rest of the time.
And
You're
don't
more
do
likely-
anything else.
Yeah.
And just sweat and get very nervous.
If you have no idea, there's always plugging in. And then you're throwing math at it, right? You know almost all the math necessary, maybe all the math necessary to do well on the test or to get everything right. If you had time and recognize exactly what you're supposed to do. If you don't know exactly what to do, throw math at it. So you might get a triangle and you say, I have no idea what I'm supposed to do. Well, you know stuff about triangles. If it has to do with angles, throw everything you know about angles at that question. You're not going to be throwing exponents at it, right? You might be doing trig, but you're throwing, so whatever seems to be related, like if you see exponents in a problem, it's probably related to that. But if you have no idea what to do, then you're cooked. Move on.
Yeah.
But throw math at it.
You can try using the answers, see if those, but the ones where it's like, what's the sum of the solutions? Obviously, you can't use those because you don't know what the solutions originally were. Putting in your own values for x, seeing what the answers are equal to if you have the same value of x. But overall, listen, this goes for everyone.
Listen.
You're not going to get everything right. So it's like if you get one where it's like, oh my god, I don't know if I got that one right. I'm not going to get a perfect score. You shouldn't be aiming for a perfect score. Aim for it, but don't actually expect to get one because they're extremely absurdly difficult to get. So just move on. It's fine. You're going to get your best score as long as you don't let these questions get to you that you know are going to be probably wrong, maybe. Don't let them hurt your confidence.
So little do you guys know that Brady's forgotten that we're streaming and he's just talking to his reflection in the glass.
I'm
talking to young Bird. That's what
Do you look at the camera? How about not making simple mistakes? Easy, don't make them.
Yeah. Take him out to the barn and shoot him.
You take them out back.
Yeah.
Don't shoot them in front of the barn.
Yeah.
Behind the barn,
Behind the barn.
where you took Old Yeller.
Is that what they did with Old Yeller?
I think so, right?
I don't know. He was yelling so much. Or was it because he was yellow? I don't know.
I think it was
Yellow
yellow.
dog.
So it was
Old
Old
Yeller
Yeller.
dog.
I think so. I don't know the story
Simple
at all.
mistakes. It's not about going back and checking your work. If you have time, go back and check your work. But it's about being accurate as you go. So always make sure you understand every part of the question.
Read all of the answers.
Yeah.
I mean, with math, it really doesn't.
That doesn't quite
require
work
it.
for math.
Yeah, but in English and grammar, or sorry, reading and grammar, yeah, you might look at one and say, oh, that looks good, and that's what I was thinking, and you don't realize that if you keep going down, you'll find one that actually makes way more sense.
Yeah.
You didn't even think about it, you know?
Yeah.
Read them all.
I would say really you need to be careful of negatives and fractions. That's where the most common mistakes are, or not reading the question the correct way. They will give you an answer. If they ask you, okay, here's a system of equations, what is x plus y? They'll very likely give you the value of x as one of the answer choices because you just solve for x and you're like, okay, I have x because that's what people do, and then you put that as the answer.
That's what people
Make sure
do.
you answer the question
Answer
that they
it.
give.
Come on.
Just answer it.
Just answer it.
Don't make simple mistakes.
Oh my
Take
gosh.
that out to the back of the barn and shoot it
Yeah.
twice.
Double tap. That's how they got
Old Yeller.
Old Yeller.
It's a good dog.
Okay, then good.
Oh,
Good.
you're so good.
Yo, Ashley, Ree Matthews, you've got this.
Yeah.
Yeah, and your hair looks good. So, you know, what else do you
You're
need?
so ready.
Yeah, you're very ready for
Make
this.
sure to moisturize right before you start.
Yes, and exfoliate.
Yep.
Exfoliate and moisturize in that order. Don't moisturize and exfoliate, because then you're just going to wipe all the moisturizer
Flip the
off.
fraction, change the sign.
Flip the fraction, change the sign. For and nor,
But
or
or
yet
yet
so.
so.
For and nor, but or yet so. For and nor.
High and tight, moisturize, exfoliate.
Yes. And always repress and dissociate.
from any negative emotions.
That's going to be it for us tonight.
Right.
Very good.
All right. Have a good night, Ring Matthews. Of course, tell us what you get eventually.
Eventually, if you're
days.
comfortable.
Tell us now if you know.
Yeah, oh man. Thanks for the stream. Thank you.
Good night. Good night, everybody else.
Good night. Go get some sleep. Nah,
Yes, go
we
get
so-
it.
we love you. Nah.
800 Matt.